Okay, let's continue our discussion of problem number 25 from AMC 12, 2015, the test B. So in this lecture, I'll discuss the most simplistic way to solve this problem. It involves least bit of knowledge. However, in order to solve it this way, you'll be approaching this problem practically without any guarantee that some of the simplifications, some of the lucky breaks that you will see will end up happening. Also, it is very arithmetic intensive. Therefore, there is much room for error. So this is perhaps the easiest, maybe it's the most reliable because the answer we get assumes the least amount of things, yet may not be the fastest, and perhaps may not be the safest because of all the potential for the error there is when you're calculating it. So let's go back to the situation. We have a B that starts at point P0. Easiest way to do this is put the P0 at the origin. Then, when we get to P1, let's call this trip the first trip. Our first trip would involve us making changes that is 1 times 1 in the length. Look at this, the x change is in the length of the arrow is 1 and is totally in the x direction. And our x direction is the east as is typically defined, and therefore we can say our north is our y direction. In this picture, our change in y is just 0. So our new coordinate is 0 plus 1 times 1, which is 1, and 0 plus 1 times 0, which is still 0. Why did I write this like in this fashion? Well, because of the next trip. Next trip, you're not going the same direction. You have turned 30 degrees up. Your length is 2. So your change in x, I hope you remember this from your trigonometry lessons, is equal to 2 times cosine 30 degrees, which is equal to 2 times square root 3 over 2. And our change in y is 2 times sine 30 degrees, which is 2 times 1/2. So our new location, our point P2 is at 0 plus 1 times 1 plus 2 times square root 3 over 2. That's where our new x coordinate is. Our new y coordinate is 0 plus 1 times 0 plus 2 times 1/2. And then let's continue on. Our point 3, our change in x is now 3 times, and since it's change in x, the cosine of a generalized angle on a generalized coordinate is always defined as something that's related to the x coordinate divided by the distance from the origin. So you're always going to have a cosine for the change in the x direction. And it's now cosine 60 degrees. And cosine 60 degrees is 1/2. Change in y. Of course, that thing is related to the sine, so 3 times sine 60 degrees. So that's 3 times square root 3 over 2. Put it all together, we have 0 plus 1 times 1 plus 2 times square root 3 over 2 plus 3 times half. For the x, and then for the y, 0 plus 1 times 0 plus 2 times 1/2 plus 3 times square root 3 over 2 for the y. So we now know that every time you take a trip, your arbitrary trip we include the changes in the x, so that xi would equal to I times cosine of I times 30 degrees. And the change in the y will always involve that I term times sine of I times 30 degrees. So this is the case for the I equals to, well, wait, not 30 degrees, I minus 1 times 30 degrees. And I minus 1 times 30 degrees here. So 1, put the I equals to 1 there, 1 minus 1 is 0, so your angle direction is 0 degrees. When your, 2, 2, 3, 3. When your x direction is 2, when you start second change, your I is 2, so you have 2 times 2 minus 1 times 30 degrees. 3, it is the 3 times 3 minus 1, which is 2, 2 times 30 degrees, 60 degrees, which is what we have. So let's see what happens if we do the full 12 changes, or where the P12 coordinate will be. Our coordinate, the x coordinate of P12 can be written as summation of I equals to 1 to 12 I times cosine I minus 1 times 30 degrees. So I used the summation symbol to explain it, but if I write the whole thing out, this is how it looks like. It is 1 times 0 plus 2 times square, 1 times 1, sorry, 2 times square root 3 over 2 plus 3 times 1 half plus 4 times 0 plus 5 times negative 1 half plus 6 times negative square root 3 over 2. And since I'm running out of room, I'm going to write 7 times negative 1 plus 8 times negative square root 3 over 2 plus 9 times negative 1 half plus 10 times 0 plus 11 times positive half, because now you're in the fourth quadrant, plus 12 times square root 3 over 2. So that just is 12 terms. Well, is there a way to simplify the situation? Well, let's look at this. If you look at this, we can just consider this as minus 6 plus 12 plus 6 times square root 3 over 2, whatever that is. Over here, minus 5 plus 11 plus 6 times half. That's 0. We don't have to worry about zeros. Plus 3 minus 9, so that's not plus. We now have negative 6 times half. And plus 2 minus 8, we have negative 6 times square root 3 over 2. And then 1 minus 7 minus 6. And then we got a little lucky. This cancels that out. This cancels that out. The total combined change for the first 12 situation, or the x-coordinate of our P12, is simply minus 6. Okay, that's simple. Can we trust our luck and hope this continues? Well, let's see. Let's see what happens if we do 13 to 24. So 13. 13 times whatever that is, 14. It's the same thing. We are working on a coterminal angle cases. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Do note that we have 1 ones here, minus 1 here. Again, if you look at this, if you combine these two, we get the same conclusion. The relative change from these two contributions is minus 6. And then if you add these, again, 14 minus 20, minus 6 again. Everything's the same. So everything that happened in the first 12 trip will happen again. So every time you increase, every time you go to the 12th term or x coordinate of a point that is p 12 times n would simply be equal to negative 6n. Yeah. N will be the how many multiples of 12 you went, and yeah, that's your coordinate. And 12 minus 6. So every time you go 12 changes, your x coordinate will decrease by minus 6. Okay, we can use this to predict where we will be at 2015. So 2015, how many times, what multiple of 12 is 2015? Well, we know that the 2015 can't be divided by 12. So let's actually do the division and see what happens. 2015, 12, 1, 12, 81, 6, 72, 95, and then 7, 84, 11. Oh, so close. Why not think of 2015 as 168 times 12 minus 1. In other words, to get the x coordinate of the point P 2015, you can think of it as 168 times minus 6, because every time you go by 12, you decrease by minus 6. And then we have to subtract whatever the 2016's change would be. And we can easily figure out what the 2016's change will be, going back to our equation that we had before. So let's do that. First, this portion. If you do that portion, well, we kind of already know what that is. That's going to be 2016 divided by 2. So this will be minus 1008. Now, what about the 2016's coordinate? So if you use the formula we got here, where I just limited to 12 since I was only looking for the first 12 points, but now since we're going all the way to 2016, use the I equals 2016, we have 2016 times cosine of, 2016, that's going to be a handful, but we know that you can just subtract 360 degrees how many times until we get a nice convenient answer for a nice convenient coterminal angle to use. So that one, the 2016 angle should be minus 30 degrees. Yeah, minus 30 degrees should be fine, yeah, in fact. If you put 2016 there, 2016 is already a multiple of 12. 12 times 30 is 360, so you're just missing a minus 30 degrees from a complete 360 degrees. So if you calculate this, is 2016 times square root 3 over 2, positive square root 3 over 2. Okay, yeah, it's positive square root 3 over 2. So we need to subtract this much from what we have here. So our P, yeah, I need the space to write this down. Our P20, our x coordinate of P2015 would be negative 1008 minus 1008 square root 3, or minus 1008 1 plus square root 3. So that's our x-coordinate. So let's write our x-coordinate right over here. Now we need to work on the y. Y, as I said before, it is very similar story, except when we look for the y, this cosine has now changed the sign. And let's first see what happens if you add up the first 12 terms for the y. We have 1 times 0, because 1 minus 1 is 0, plus 2 times sine 30 degrees, which is 1/2, plus 3 times square root 3 over 2, plus 4 times 1, plus 5 times square root 3 over 2, plus 6 times half. And then 7 times 0, plus 8 times negative 1/2, plus 9 times minus square root 3 over 2, plus 10 times minus 1, plus 11 times minus square root 3 over 2, plus 12 times minus 1. Again, compare. Zeros, we don't need to think about. This one, plus 2 minus 6 give us minus 6 times 1/2. 3 minus 9 minus 6 times square root 3 over 2. 4 minus 10 give us minus 6. 5 minus 11, minus 6. Yeah, I was so hoping for a cancellation, but we didn't get it. They add up instead of cancel. And then finally over here, minus, what did I do? Yeah, that's 1/2. Minus 6 times 1/2. Gather like terms, we have this and this gives us another minus 6. So put together we have minus 12 here, and then if we put these together, we have minus 6 times square root. So every 12 changes will give us minus 12 minus 6 square root 3. And since we gotten this number by comparing the difference between the second term and eighth term, if you go to, for example, 13, then 14th term, and then you'll get to 18 here, so 19, 20th term, again, you're gonna get the same difference of minus 6. The whole thing you saw will happen again and again and again. So, generalized y coordinate for point P of, again, since it's 12, 12n would look like minus 12n minus 6n times square root 3. So there we are generalized y coordinate. For the 2015, again, we can think about this as y of P2016 minus the delta y of 2016. The same trick we used for the x. This one, we now have a simple formula to calculate. This one is simply minus 2016 minus 1008 square root 3. Our delta y, again looking at this formula, we can see it is minus 2016 sine of, yeah, we already did this with the x coordinate, so it's minus 30 degrees again. Or the angle of 2015 times 30 degrees is coterminal is minus 30 degrees. And minus 30 degrees, oh, that one, lucky us, is simply negative 1/2. So that minus that, our final y coordinate will be minus 1008 square root 3. So we now have a coordinate of the 2015. Looking at this, whoa, x and y value happens to be the same thing. Okay. So by some interesting coincidence, we arrive at a point where it's actually, we're at the y equals to x line. Now, we want to know what's the distance this point from the origin. Well, we know that if since we're going from the origin, a distance of point A would be at distance of a times square root 2 away from the origin. Since we have the same numbers over here, we can see our distance is equal to absolute value of negative 1008 times 1 plus square root 3 times square root 2. Yeah, I should have had an absolute value here as well. We can just distribute this thing inside and we get our answer of our final distance is 1008, and put this in, we have square root 2 plus square root 6. So our distance written out in the form that is requested by the problem is 1008 square root 2 plus 1008 square root 6. And then what's really being asked is, what is the sum of this number, that number, this number, that number? Add them together. These two adds up to 2016. These two adds up to 8. Answer should be 2024, which is B. So there you have it.